alaikum everyone. This is me Sibka Mursaleen and my group partner Mohammad Hassan Kareem. Today we are going to explain our OS project named Miniproc OS. Miniproc OS is a lightweight and efficient operating system designed to stimulate core process management tasks with simplicity and innovation. Miniproc OS integrates key functionalities like dynamic process scheduling, memory management, file system integration, threaded execution. Now, Hassan will explain you the code.
Thank you, Sibha. So let's get directly started from our code. Before getting to our code, keep in mind that this program is written in C but mimicking original OS. It is covering a aspect of execution of OS. For that, we have included libraries, libraries that we will use, state of process, ready, running, and terminated, and we have made a structure to store information of process like its id, state, priority, its name, memory allocated to it, and as we are dividing process into threads, so their thread ids. And this is the part where we have limitations in our program. Here we have 10 programs at a time to execute or processes, and this will count the number of processes, and this is the limitation where we are using only 1200 memory, and this variable will use to see how much memory is being used. Starting from this function, we have multiple functions in it. Starting from this function will get the size of each file you enter or each program you enter, and this function will allocate memory to your programs or your files. And this function will use to deallocate memory. Deallocate means to free up the memory, as we do not need that memory or we do not want that process to retain that memory. So after that, this will deallocate memory. After deallocating, or we have this function, read file function, that will read the code from your file, and this function that will use to execute your program. This will print the file size and the memory allocated to your program, and if your program get any error, it will let you know. After that, we have the create process function. This function will actually create your program in process, or you can say change your program in process, as process is a running program. So this will create your process. Our maximum limitation is 10. You cannot exceed the file size of 10. And if we get any error, or if our program get any error regarding opening file or something else, so it will generate error. So this is the part where our program change in process and tell you about their IDs, their memory allocation, file size, and all of this. After that, we have a scheduler function. That is the main function. This function is used to schedule all the processes you have entered. Processes, or you can say the program in running state, their processes, so it will schedule them. We have chosen priority based scheduling, but we have many other priority schedulings too. Schedulings that true, but we have used highest priority. So this will schedule as well as join your threads. After that, we have the main function, or you can say the kernel of our operating system, or the entry point of our operating system. In this, our program first check if you have entered at least two programs. We are using actually scheduling part, so we need at least two programs so that we can execute them. After that, it will create the process programs. After creating, schedule them through scheduler function and free the memory after they are easily, or you can say the smoothly executed.
When the Miniproc OS code is executed on the command line interface, the following results and outputs are displayed step by step. First of all, it displays messages confirming the creation of each process. Second, the scheduler selects the process with the highest priority. The lowest file size would get the highest priority and highest file size would get the lowest priority. Logs indicate the process has been started. When a process is executed, the program output logs showing its execution and state changes. If a command from the process fails, error messages are displayed. Logs detail memory usage. Allocation is shown when a process starts and deallocation is logged after termination. If memory cannot be allocated or file is missing, clear error messages are displayed. After all processes are executed, the CLI returns a final summary of terminated processes and memory statuses. These outputs provide a comprehensive view of systems operation from process creation to termination, highlighting scheduling efficiency, memory management, and error handling. Thank you.